This is the problem here. If a1, a2, a3 dot n is an arithmetic progression with a common difference r, we have to determine the difference between the square of its mean, that is square of the mean of this arithmetic progression, and the mean of its square terms of this same arithmetic progression. We have to find out the difference between the square of its mean and the mean of its square terms. Now let us begin. Here the arithmetic progression is a1, a2, a3 dot n. This is the arithmetic progression a1, a2 dot n. Here common difference is r, that is a1, a2 equal to a1 plus r, a3 equal to a1 plus 2r, and so on, n equal to a1 plus n minus 1 into r. This is the last term of this arithmetic progression. So the mean of this arithmetic progression, mean is assumed as a bar. A bar is taken as the mean of this arithmetic progression. A bar is taken as the mean of this progression so a bar equal to a1 plus a2 plus dot n over n. This is the arithmetic progression of the term of this. This is the mean of this arithmetic progression, that is mean of these terms in this arithmetic progression. This is, so we can write a1 plus a2 is equal to a1 plus r, a3 is equal to a1 plus 2r, and so on. Last term is a1 plus n minus 1 into r. This is over n. This is over n. So we can write here number of a1 is n, number of term is n. So the summation of a1 is na1. Summation of a1 is na1 because a1 is the number of a1 is n, that is number of terms. So summation of a1 is na1, and plus r plus 2r plus dot n minus 1 into r, that is over n. This is equal to a1 plus, here this is also an arithmetic progression. So we have the sum of this arithmetic progression. We have already known the formula for the sum of an arithmetic progression. Here progression is r plus 2r dot n minus 1 into r. So the sum of this arithmetic progression is, we use the formula for the summation of arithmetic progression. Formula is number of terms. Here number of term is n minus 1. So formula is number of term is n minus 1 over 2 into first term. First term is r and last term is n minus 1 into r. That is, this is the formula for the sum of the arithmetic progression. This is equal to a1 plus r into n minus 1 over 2 into 1 plus n minus 1, that is a1 plus n into r into n minus 1 into n over 2 over n, that is, this is over n over n. So this over n over n, this is equal to a1 plus this is equal to n is cancelled out, so r into n minus 1 over 2. This is the sum of this arithmetic progression. Arithmetic progression is r 2r and dot dot n minus 1r. The summation of this arithmetic progression is got as this, r into n minus 1 over 2 into n, and we divide by n this summation. This summation is divided by n, so we get r into n minus 1 over 2. Summation is this. This is the summation of this arithmetic progression. This is so square of the mean is equal to a1 plus r into n minus 1 over 2 square. This is equal to a1 square plus 2ab, that is a1 into r into n minus 1 plus r square over 4 into n minus 1 square. This is the square of the arithmetic mean of this, of the term of this arithmetic progression. This is the square of the mean of the terms of this arithmetic progression, which is equal to this. So next we calculate the mean of the squared terms of this arithmetic progression. Lastly, next we calculate the mean of the squared terms of this arithmetic progression. Squared terms are a1 square, a2 square, a3 square, and so on, an square equal to a1 square, a1 plus r square, a1 plus 2r square, and so on, a1 plus n minus 1 into r square. These are the squared of this. These are the squared terms of this arithmetic progression. Arithmetic progression is this. So these are the squared terms of this arithmetic progression. So we can take the mean of these squared terms as a square bar. This is the mean. This is the mean of the squared terms of the arithmetic progression. Equal to, which is equal to a1 square plus a1 plus r square, a1 plus 2r square dot dot a1 plus n minus 1 into r square over n. This is the mean of the squared terms of this arithmetic progression. This is the mean of the squared terms of this arithmetic progression. The arithmetic progression was a1, a1 plus r, a1 plus 2r, and so on. Lastly, last term is a1 plus n minus 1 into r. This is the mean of the squared terms of this arithmetic progression. This is, so we can write a1 square. If we expand this, we get a1 square plus 2a1r plus r square. Also this is equal to a1 square plus 4a1r plus 4r square, and so on. Lastly, we get a1 square plus 2a1 into n1 into r plus n minus 1 square r square. 2a1 into n minus 1 into r plus n minus 1 square r square. This is, so over n, also over n. This is the mean of the square terms. So this is equal to, here number of a1 square is n. Here number of a1 square is n. So sum of this a1 square is n a1 square. Number of a1 squares is n. So sum of this n a1 square is n a1 square. And also number of also we can write 2r a1 2a1r, sorry, we can write 2a1r into 1 plus 2 plus dot dot 3 plus dot dot n minus 1. This is, and we have also got r square we can also factorize this term. After factorization, we get r square into 1 square plus 2 square dot dot n minus 1 square. This is over n. This is equal to a1 square plus 2a1r into, this is the sum of this arithmetic progression. We have already known the formula. Formula is number of terms is n minus 1. So n minus 1 over 2 into 1 plus n minus 1. This is, and also here this is the well known series, square term of the arithmetic progression 1 to 3 dot dot n minus 1. So we have already known the formula for the sum of this series, that is square term of an arithmetic progression which is 1 2 3 4 dot dot n minus 1. This is the sum of the square term of that arithmetic progression. We have already known the formula for this sum. The formula is number of term is n minus 1, that is n minus 1 into number of term, here number of term is n minus 1, number of term plus 1 into number of 2 into number of term plus 1 over 6. This is the sum of this well known series, that is 1 square 2 square dot dot n minus 1 square. This is the sum. So we have a1 square plus 2 is cancelled out, here a1 into n minus 1 into r into n into n. Here also this over n, and here also we have n a1 square plus r square into n minus 1 into n into 2n minus 1 over 6 over n, this over n, which is equal to a1 square plus a1 into n minus 1 into r plus r square into n minus 1 into 2n minus 1 over 6. This is the sum of the mean. This is the mean of the squared terms of this arithmetic progression, which is given as this, that is a1 a2 a3 dot dot n, also a1 plus r, a1 plus 2r, and dot dot a1 plus n minus 1 into r. This is the mean of the square term of this arithmetic progression. So the difference the required difference is a square bar minus a bar square equal to a square bar. This is a square bar. This is a square bar. That is the mean of the square term of this arithmetic progression. Mean of the squared terms of this arithmetic progression, which is taken as a square bar. So difference is this. A square bar is got as this, that is a1 square plus a1 into n minus 1 into r plus r square into n minus 1 into 2n minus 1 over 6 minus the square of the mean of the arithmetic progression. Square of the mean is a bar square, which is got as this. So a bar square is equal to this, that is a1 square plus a1 r into n minus 1 plus r square over 4 n minus 1 square. This is so we can get a1 square plus a1 r into n minus 1 plus r square n minus 1 to n minus 1 over 6 minus a1 square minus a1 r into n minus 1 minus r square over 4 n minus 1 square. This is we can cancel out these terms, that is a1 square, and these terms a1 into r into n minus 1 are cancelled out. Two terms remain. The two terms, first term is this and second term is this. These two terms remain, and we can subtract this from this we get, after subtracting this from this we get r square into n minus 1 over 2n minus 1 over 3 minus n minus 1. This is equal to r square n minus 1 over 2, r square into n minus 1 over 2. We can subtract this from this. After subtracting we get 2n minus 1 minus here also over 2, n minus 1 over 2, that is this is equal to 4n minus 2 minus 3n plus 3 over 3 over 6 over 6. This is equal to r square n minus 1 over 2. Here we get n plus 1 over 6. This is equal to r square over 12 into n square minus 1. This is the required sum. That is s square bar minus a bar square. This is the required sum. That is the sum is this is the required difference. This is the required difference. Here difference between the square of the mean of the arithmetic progression and the mean of the square term of this arithmetic progression. We have to find out the difference between the square of the mean of the arithmetic progression and mean of the square term of the same arithmetic progression, which is got as this. This is the required difference.